Hello Math 2 students, and welcome to your 5.2 Ed Puzzle. So today we're going to actually start out with a warm-up. So it's kind of a little bit of a review of what we did yesterday. So for the first one here, it says find x and angle RQS. All right, so they want you to solve for x here. So I want you to think, we've got these two angles here, and they do make a straight line. So I want you to try and set up an equation and solve for x. So these two angles, since they make a straight line, they make a straight angle, they're going to add up to 180. The measure of this entire angle is 180. So we'll say x plus 100 plus 2x plus 8 equals 180. All right, and then we can combine like terms. So we get 3x plus 108 equals 180. And then we're going to subtract the 108. Whoops. And 180 minus 108 is 72. So we get 3x equals 72. Divide by 3, and we get x equals 24. All right, so that answers the first part. We got what x equals. Now, they want us to figure out what angle RQS is. So, we're going to go, that's angle RQS. We're going to plug in 24 for x. We're going to say 2 times 24 plus 8. It's going to give us 48 plus 8, which is going to give us 56. All right, so we'll say the measure of RQS equals 56 degrees. Awesome. Next one. So it says, find x and the measure of FOG, HOG, and JOH. All right, so first, go ahead and find the value of x. If you see, these make a straight angle. So you can go ahead and add all of them up and set them equal to 180. So you'll say 4x plus 3x plus 2x equals 180. 4 plus 3 plus 2 is going to be 9x. And then we can divide by 9 and get x. 180 divided by 9, we get x equals 20. All right. So now we have to go through and find the angle measures here. So, let's go ahead and try and find the measure of angle FOG. All right. So we got to take what x equals. And to find FOG, we're going to use 4 times x. So 4 times 20 is going to give us 80. So we know the measure of angle FOG is going to be 80 degrees. Then we'll do HOG. So we'll say 3 times 20, right? Because HOG is equal to 3x. And we get 60. And then we got our last one here, which is JOH. All right, so we'll do 2 times 20, which gives us 40. So we got the measure of angle JOH equals 40 degrees. So that was a lot. We had to find quite a lot there. And then that was our other piece of information. All right, so now let's go ahead and kind of get into what we're doing today. So we're really digging into triangles today. So first we're going to talk about some different kinds of triangles. We've got a scalene triangle, and that's a triangle where no sides are congruent. So that means that none of these sides have an equal length. Then we've got an isosceles triangle. So it's a triangle in which at least 2 sides are congruent. So what that means is that this side is congruent to that side. All right. Then we've got the legs, the congruent sides of the triangle. So here, the legs would be DF and DE, because those are the congruent sides of the triangle. Then we've got the vertex angle. So that is the angle formed by the legs of an isosceles triangle. All right, so the vertex angle would be this guy. Maybe we can even label him. We'll label, let's say this is our vertex angle. And then we can, I'll change it to this gross green color. And we can say that these green guys are the legs. And then the base is the third non-congruent side of the isosceles triangle. So, oops, this guy here is our base. That's the side that's not congruent with the other two sides. And then we have an equilateral triangle, which is a triangle where all sides are congruent. So I know this triangle is kind of in a random spot here, but that would mean that all of these sides are of equal measure, all right? And then an equiangular triangle, a triangle where all angles are congruent. So if it's equiangular, that would mean that it is also equilateral, and you've got equal angles throughout as well. Next it says, if two sides of a triangle are congruent, then the angles opposite them are congruent. So this is actually very important. So let's think about that again. If two sides of a triangle are congruent, then the angles opposite them are congruent. So let's go back and look here. We said that these green angles are congruent, right? These are our congruent sides. So that means that the angles opposite them are congruent. All right, so because these two sides are congruent, the angles opposite or across from them are going to be congruent as well. Next, it says if two angles of a triangle are congruent, then the sides opposite them are congruent. So that's kind of, before we were given that the sides were congruent, and we assumed by the theorem that the angles were congruent. Well, now, if we know that the angles are congruent, you can say, well, if those are congruent, these guys are congruent. All right. So let's go ahead and try example 1. It says solve for x. All right. So they do have these little tick marks here, which these mean that those two sides are congruent. So we actually have we have definitely an isosceles triangle happening here, right? We got two sides that are congruent. And using this theorem, all right, if two sides of a triangle are congruent, then the angles opposite them are congruent. So we can use that idea. That means that these guys are going to be congruent. And if this guy's 50, that means that this guy needs to be 50. That's kind of bad. Hard to read there, I guess. 50. Oh, whoa, whoa, whoa. There we go. 50 degrees. So now it says solve for x. So it's actually a super easy problem now. We've got two angles of a triangle. How do we find the third? Right? All three angles of a triangle always need to add up to 180. So we could say 50 plus 50 plus x equals 180. So we get 100 plus x equals 180. Subtract 100. You get x equals 80. All right, let's try the next one. It says solve for x and y. Ooh, so there's a lot of stuff we need to solve for here. But we could go ahead and use kind of some of our theorems here to solve for these variables. So again, we're going to go back to this, this theorem here where it says if two sides are congruent, then the angles opposite them are congruent. So that means that these two angles here are going to be congruent because these two sides are congruent. So that means that we can set them equal to each other. So we can say 3x plus 5 equals 2x plus 10. And now we just need to solve. So go ahead and solve that for me. So you're going to want to do a minus 2x. You get x plus 5 equals 10. Minus 5, you get x equals 5. You should have gotten something similar. You may have solved it slightly differently than I did, but you should have gotten the same end result there. So you've gotten what x is, all right? So now we need to go ahead and solve for y. So what we can do here is we could figure out what these angles are equal to. If we know what x is, we can go ahead and plug in. So for this guy, we could do 3 times 5 plus 5. So all I did here was plug in the x value. You'd get 15 plus 5, which would give you 20. All right. And of course, you could plug into this guy, right? You could do 2 times 5 plus 10. But we know that these are congruent, so if this guy's 20, that means that this guy is 20. And now we can go ahead and set up an equation. We have 2 angles of a triangle, and we're trying to find the third. So we're going to say 20 plus 2y equals 180 degrees. We get 40 equals 2y, 40 plus 2y equals 180. Minus 40, and we get 2y equals 140. Divided by 2, and we get y equals 70. All right, you guys are doing a good job. We got 2 more to go. So for example 3, it says if the perimeter of angle EFG is 32, is EFG scalene, equilateral, or isosceles? So perimeter is what you get when you add up all of the sides. So they basically are telling us if you add up all the sides, you get 32. So we can go ahead and solve for x, right? You could say 10 plus x plus 7 plus 2x minus 3 equals 32. So all I did is I added up these sides. I said 10 x plus 7 and, oh, we already did blue. 2x minus 3 is equal to this perimeter of 32. So now we can go ahead and solve. Combine like terms, we get 3x and then 17 minus 3, which is going to be 14 equals 32. We do minus 14, 32 minus 14 is equal to 18. You get that x is equal to 3. Or I'm sorry, x is equal to 6. My bad. All right, so we've got what x is, and now we have to figure out, okay, do we have a scalene, equilateral, isosceles? So to review, a scalene means that none of these sides are equal. Equilateral means that all of the sides are equal. And isosceles means that 2 of the sides are equal. So let's go plug in x. If we plug in a 6 for x here, we end up that this side is equal to 13. And if we plug in a 6 for x here, 2 times 6 minus 3 is going to give us 12 minus 3, which is 9. So this means that our 3 side lengths are 3, 10, and 9. So if our 3 side lengths are 3, 10, and 9, do we have a scalene, equilateral, or isosceles? So we have a scalene triangle here. All right. So last one here, it says if triangle CAT is equilateral, what are the values of x and y? All right. So if it's equilateral, that means that all 3 sides need to be equal. And they did give us a side length here of 15. So that means that all of these need to be 15, right? If that's 15, that means this needs to be 15. And this needs to be 15. So what we can do is there's actually 2 different ways we could do this. We could set these equal to each other. Or we could just set one of them equal to 15. I'm just going to set one of them equal to 15 because we know that that's what we're looking for here. And you know, I'm thinking this might be a typo. So let's go ahead. We'll set this equal to 15. So we'll say 3x minus 3 equals 15. And we'll say plus 3 plus 3. We get 3x equals 18 divided by 3, and we get x equals 6. So we know that this guy is going to be equal to, this x is equal to 6. Now, I think this other one was supposed to be a y, so maybe on your paper change this to a y, okay? Because they said solve for x and y, and there's only x's. So we'll go ahead and we'll set y plus 8 equal to 15. All right, so we'll do minus 8, and 15 minus 8 is equal to 7. So we get y equals 7.